The growing interface of population and natural resources raises concerns over land use, economic growth, and environmental impact. Development along rivers, waterways, and floodplains places new demands on flood control. Rivers and flash floods threaten property and even lives. But these rivers are a natural resource that must be preserved and protected. The soil cement solution, protecting people, property, and the environment. From its original use as a base for pavements, this simple mixture of cement, soil, and water has emerged as an economical material for flood protection. Soil cement is a strong and effective solution for stream bank protection, riverbank protection, grade control structures, and slope protection for reservoirs and low permeability liners for lakes and lagoons. Soil cement is a mixture of soil, cement, and water. This mixture is blended, transported, spread, compacted, and cured to form a strong, durable material that resists erosion. Almost any type of soil can be used to make soil cement, although granular soils are preferred over clay soils. Simple laboratory tests determine the requirements for cement content and density. Material meeting these requirements is readily available at most job sites. The amount of cement to be added varies depending on the soil type and gradation. In general, increasing the cement content improves the strength of the soil cement. And like concrete, soil cement will continue to get stronger with age. Soil cement is a natural-looking, cost-effective method for protecting stream banks from erosion during floods.
As with most rivers in the desert Southwest, you don't see water in the river today. But the soil cement flood protection being provided here today will protect the adjacent land for home, commercial, and industrial development.
For the city of Santa Clarita, California, soil cement bank protection meets economic, engineering, and environmental goals.
Since 1999, 5.5 miles of soil cement bank protection have been constructed along the Santa Clara River and its tributaries. Although the river's not flowing today, design flows in the Santa Clara River are 120,000 cubic feet per second with heavy debris loads and high velocities up to 20 feet per second. These City of Santa Clarita ball fields have historically been eroded due to flooding from the Santa Clara River every 2 to 4 years. The damage has been significant. In fact, the area where I stand 2 years ago was eroded and completely lost to the river. Through the implementation of soil cement bank stabilization, we've been able to stabilize the river banks here and provide permanent flood protection for the ball fields. Now it's a long-term amenity to the community.
As one of the last unpaved rivers in Los Angeles County, keeping the Santa Clara River in its natural setting was of paramount interest to the city planners and environmental groups within the community.
We were convinced to use soil cement as bank protection after we conducted a thorough research and investigation into the important qualities of soil cement. The soil cement bank protection is constructed first by excavating a large trench, and then through the use of a batch plant on site, the soil, the cement, and the water mixed at certain specification, and then it's placed in the trench in 8 to 12-inch lifts, and then compacted with vibratory compactors, watered down, and brought up in lifts up to the top of the bank elevation. Once the soil cement levee is brought up to its design elevation, then the outer bank is filled with native soils and planted with native riparian vegetation.
Quality control is always a critical aspect to soil cement construction. And through the use of on-site batch plants that are highly automated, the project meters cement, water, and the mixture of the aggregate, the soil material that's used to create soil cement.
Riverbeds can also be protected through the use of soil cement grade control structures. These drop structures change the slope of the channel to slow the velocity of the water, reducing the potential for erosion.
The purpose of the grade control structure is to create a hard point within the river system to prevent long-term lowering of the stream bed.
At Tampa Bay Regional Reservoir, soil cement, placed by the stair-step method, protects the slope from severe wave action generated by hurricane-force winds.
We're currently standing on the stair-step portion of the armored embankment. Below the water line is our flat plate portion. It's for erosion protection. This portion is also for erosion protection as well as wave energy dissipation.
Soil cement's been a true home run for the city of Santa Clarita's ball fields.
So what we're able to do with soil cement is to be able to orient a community onto the river, because we know that the soil cement will protect in times of major storms.
It's environmentally sensitive. It allows for multi-use activities for the community, and it provides a very high level of flood protection.
The soil cement solution, protecting people, property, and the environment.